In this video, I'm going to show you how to build a web scraper that extracts product search results from Amazon.com. This project is designed to give the beginner or intermediate programmer some experience with web scraping in a practical application. Some basic working knowledge of Selenium and BeautifulSoup is assumed by the lesson content. Additionally, you'll need to have installed the related Python libraries, as well as the webdriver of your choice. I'll provide links to Selenium and BeautifulSoup in the description, and check the video link above if you'd like to install the webdriver for Microsoft Edge. I'll provide instructions with Microsoft Edge in mind, however, I'll highlight the few differences that exist for Firefox and Chrome browsers so that you can follow along with any of those webdrivers. I'm going to be demonstrating this in a Jupyter notebook, but please feel free to use any IDE or code editor that you wish. To start, let's import the required project libraries. CSV, from BS4 import BeautifulSoup. If you're using Firefox or Google Chrome, from Selenium import WebDriver. If you're using Microsoft Edge, from msedge-selenium-tools import Edge options. The next thing we're going to do is begin an instance of the WebDriver. For Firefox, use driver equals webdriver.firefox. For Chrome, it's webdriver.chrome. To use Microsoft Edge, you need to first create options. And then you need to set the use Chromium flag to true. And finally, create the driver with Edge, and then pass in options equals options as the argument. Now that the WebDriver has started, let's navigate to Amazon's website. You can see the URL on your screen. We're going to use the get method of the driver, and pass in the URL as the argument. Now, there's a few ways we could conduct a product search. The first is to automate the browser by finding the input element here, and then insert the text, and then send a return key command to the browser to submit the command. However, this kind of automation, while it's fun to write, is unnecessary, and it creates potential for program failure. The rule of thumb for automation is to only automate what you absolutely need to when web scraping, because it's the slowest method for web scraping data, and there's a lot more potential for error. Let's type in a search term into the browser and then press the enter key. You'll notice that the search term has been embedded into the URL of the site. Now, we can use this pattern to create a function that will build the necessary URL for our driver to retrieve. This will be much more efficient in the long term and less prone to program failure. Let's copy this pattern and then create a function that will insert the search term using string formatting. So I'm going to assign this to a template variable. I'm going to delete the ultra-wide monitor text and replace it with curly braces. This is where we're going to insert our search term. Next, I'm going to replace every space in the search term with a plus to conform to the URL convention. And then finally, I'm going to return the template URL with the search term inserted with string formatting. Now we have a function that will generate a URL based on the search text that we provide. Now let's try this again. This produces the same results as before, navigating to the ultra-wide monitor search results. Try it again with a few different search terms if you wish. The next thing to do is to survey the page content and structure. I know that I want to extract data for each record, and all the records appear to be fairly consistent in structure, but there are a few oddities that we'll need to deal with. First, I see that there's sponsored results. We might want to consider removing these, but we'll keep them in for now. There's obviously sections that are ads. Finally, there's multiple pages of results, so we need to work out how to navigate to the next page and continue extracting results. Next, we're going to extract the content of this page from the HTML in the background. Before we do this, we need to create a soup object, which will parse the HTML content from the page source. So let's create a soup object using driver.pageSource to retrieve the HTML text, and then we'll use the default HTML parser to parse the HTML. What I want to do first is try to identify something unique about a record that will enable me to extract all the records from this page as a collection. So what is unique about a record? Well, the best way to find this is to use the document inspector. So right-click on the item you want to inspect, such as the heading, and click on Inspect. On the right-hand side, or the lower side of the browser, a document inspector will show the HTML content in the background. If you hover over an HTML element, it should highlight the element on the web page so that you can see the element on the page related to what you're hovering over in the code. What I'm looking for is the HTML tag that encloses the entire record. And if you look at what's being highlighted, it's easier to spot if you found it. Once you've found the appropriate tag, you must find a way to identify it uniquely amongst all the other tags of its name. A div tag, for example, is pretty generic, but often you can use a class, an ID, or another property to identify its group so that you can extract it. In this case, ID is a bit too specific, and it appears that class might be a bit too broad here. You'll find out as you do this more and more that it's a bit more of an art than a science, so sometimes you have to try a few things before you find something that works. Given the available fields, it appears that the class sResultItem or the data component property with its value of sSearchResult would be good options to identify the record. Since the data component type appears to be a bit more specific than the class, I'm going to go ahead and use it instead. Let's use the soup object we created previously to extract all elements with the data component type of sSearchResult. So we're going to assign the results variable to soup.findAll, and then we're going to find the div tag, and we're going to find the div tag that has a data component type property with a value of sSearchResult. If we print the length of the results list, we'll see that it returns a bit more than the results supposedly returned from our search. The difference here is the additional sponsored content that's inserted into the search. And you can do the math, the amount of sponsored content is not insignificant. Okay, now that we've identified the collection of records from the page, what we need to do now is prototype the extraction of a single record. And after we've gotten that down, we can apply this model to the entire record set. So let's assign the first result to the variable item. Now back to the web page. The most obvious piece of information we need to extract is the record header or description. If you right-click and select Inspect, you'll be able to see the HTML code behind that. Sometimes you may need to click Inspect a few times to get the level of detail that you need. We can see immediately that this element is several layers. It includes both the hyperlink and the text with the A tag that lies inside that H2 tag. And it appears that the most easily identifiable tag here would be H2. And since it's likely to be the only H2 tag in this record, we can use a very simple property tree navigation to extract it. So type A tag equals item.h2.a to assign that A tag to the A tag variable. Then we'll use A tag.text. The text property of the A tag will be the description. And you can see that there's some extra space on the edges. We can remove that with the strip method. And then next, the A tag has an href property, and that is the URL that we want. Now, it's not a complete URL, so we'll need to prepend it with HTTPS and then the Amazon website. And then we'll save that or assign that to our URL variable. The next item we need to get is price. So right-click on the price and inspect it. As you can see, the price is nested in several layers of tags, and there appears to be tags containing the parts as well as the entire text of the price. From what I can tell, we could potentially grab the A off-screen class of the span tag here. That might be a bit too generic. A safer but more verbose path would be to get the A price class first as the parent, and then grab the span underneath that with the A off-screen class. But we can get the text of this price as follows. So we'll use the item, and we'll use the find method. We want to find the span with the A price class. Now that we have the parent, we'll use the parent and we'll use the find method on that to find the span with a class of A off screen. And then we just want to use the text on that. The next two things that will be interesting are the rating out of 5 and the number of reviews. So right click on the stars and click Inspect. If we dig in, it looks like we can easily identify this with the I tag. So let's go ahead and assign that to our rating variable. You can do item.I, and you can see the rating there. And to get the text, we just use .text. Next, if we inspect the count of reviews, we can see that there isn't really much to work with here, but there is a dir property that will allow us to access this item if we combine it with the class size a base, and I would do that because the dir property and the class property are going to create a more unique combination, and this will make sure that we can identify and tag this item that we want. So let's go back, and we're going to use two properties here, the class and the dir. So use item.find, we're going to find a span, and the properties that we want are, and we'll pass it as a dictionary, the class with a value of a size base, and then dir with a property of auto. And to get the text, we just used .text on that result. And that's all we're going to grab from each record for this exercise. But if there are additional details that you want to grab, you can repeat the steps we've just gone through for each of these additional items. Now that we've prototyped a method for a single record, it's now time to generalize that pattern within a function so that we can apply it to all the records on the page. Fortunately, we can copy and paste a lot of the code we've already written. So let's go ahead and create a function called extractRecord, and we're going to pass in item as an argument. And then what I'm going to do is I'm just going to copy the pieces that we've already created. And then I'm going to create a tuple that contains these items, and I'm going to assign it to a result variable. So in that, I'm going to put description, price, rating, review count, and URL. And then I'm going to return that tuple as a result. Now we can apply that pattern to all the records on the page. So let's go ahead and create a records list that's empty. It's going to contain all of our extracted records. Then we're going to use the same results pattern that we used above to collect all of the results on the page to iterate through. And now for each item in the results, we're going to append the return value of this extract record function that we just created, passing in item. Now, as you can see, we've got an error here. And what's happening is that our model assumes that this information is available for each result. However, believe it or not, there are records without prices, without rankings or ratings. And what happens is it's looking for this text in an empty object. There's nothing there. So it gives you an attribute error. So what we need to do is add some error handling to our function. Now, if there's no price, I don't really care because it's not available, which is why there's no price. But if there is no rating or review, I still want to see the item, so I'm going to assign an empty string to those variables. So let's go ahead and use a try except, and we're going to wrap this with an attribute error as the exception. And I'm just going to return if there's an attribute error on the product price, because I don't care about it. However, if there's an attribute error on the rating or review, I want to assign empty values to those. Now, I suppose I could do rating and review independently, but for now, I'm just going to lump them together. Okay, now the only additional adjustment I need to make is that in my loop, I need to go ahead, I'm going to go ahead and copy and paste this from the prior example. I need to check to see if what I return from the function is empty or not. So I'm going to go ahead and assign the extract record result to a record variable. And then if the record has something in it, so if record, then I'm going to append that to the records list. And if we want to check the data, we can print the first record, and then we can print all of the prices in the list so far. The next step is to navigate to the next page. One way to get the next page is to find the button with the WebDriver and click it. Now this does work, but there's an easier way, and that's simply to extract the URL from the button link. This will take us directly to the next page without having to resort to unnecessary automation. However, there's an even easier way, and I didn't even notice it till I started preparing for this video, and that is simply to adjust the query in the URL. So if you click the next button and then you look up at the URL, you'll notice that there is a query parameter added to the URL for page number. Any search that you do with Amazon will result in a maximum of 20 page results. And this means that we can add this page query to the URL using string formatting. Then we can request the next page until we've extracted from all 20 pages. To make this easier, we can just simply modify our getURL function that we've already defined. So let's copy and paste that. And then what we're going to do is we're going to assign to a URL variable template.format. We're going to pass in our search term, which is what we did before. And now we're going to add to that the and page and then the curly braces. And this is going to give us a place to insert with string formatting the next page number. And then finally we can return the URL. Okay, now that we've accounted for pagination with our URL and we've generalized the page data extraction, we can put all of this together and scrape the search results for all 20 pages. So what I'd like to do here is just consolidate all of the code that we've written into one block so that you can see it all together. So let's go ahead and copy and paste our imports. Now I'm going to put edge options, edge and edge options. If you're using Firefox or Selenium, go ahead and do that. I'm going to copy and paste the getURL function. Let's copy and paste the extract record function. And finally, we're going to create a main function. Now this main function is basically going to give the instructions to do everything we want. So what I'd like to do is go ahead and create the main function and have it accept an argument of the search term. And then it's going to run the search for us and save the data based on that search term. All right, so the first thing we need to do is start up the WebDriver. Now I'm using Edge. Go ahead and start up with Firefox or Chrome per the browser that you're using. Next, I'm going to create the records list. I'm going to set a URL with our search term that we've passed into the main function. And then I'm going to iterate over 20 pages. So what I'm going to do here is for page in range 1 to 21. And the reason I'm using that is because page 1 is the first page and page 20 is the last, but because it's not inclusive of the last number in the range, I need to go to 21 to make sure that I stop at 20. And then I'm going to do driver.getURL.format, pass in the page number, and then I'm going to do what we've already done before. I'm going to create my soup object. I'm going to extract all of the results on the page. And then for each of those results, I'm going to extract that record data and append it to our records list. This is stuff that we've already done. I'm just refactoring it into this function here. Now, after we've done that for every page, what we want to do is close the driver with the close method. And then finally, we can save the data to our CSV file. Now I have a generic results.csv file name here that I'm going to use, but feel free to name it anything you want. You can even add the current date if you want with the date time library. All right, now that all of that is created, I can now run the main program. So go ahead and type in main and then pass in the search term that you want. I'm going to use ultra wide monitor, and let's see what happens. Excellent. And that's how you create a web scraper for Amazon.com. I hope you enjoyed this video. If so, make sure you hit that like button and subscribe for more content like this in the future. See you in the next video.